All right, we're going to do one last example where we're trying to show, to decide whether we converge absolutely, conditionally, or diverge. All right, so when you look at this example, maybe it jumps out at you that this is an alternating series. I know it jumps out at me. Whoops, we started at the wrong place. Let me fix that. Okay, so this guy is an alternating series, so let's just start with the alternating series test. All right, so this is alternating, yes. The limit of the terms as n goes to infinity of 1 over log n is equal to 0, yes. And 1 over log of n plus 1 is less than 1 over log of n for all n. Yes. This is because, so log of n is an increasing function, so 1 over log of n is a decreasing function. All right, so by the alternating series test, this series converges. All right, that lets us rule out the possibility that it diverges. To work out whether it converges absolutely or conditionally, we need to know whether or not the series 1 over the sum of terms from n equals 3 to infinity of 1 over log of n converges or diverges. Let's try the limit comparison test with this guy. Okay, so I hope you have some feeling that 1 over log of n is probably going to diverge because log of n goes to infinity super slowly. So 1 over log of n is approaching 0 super duper slowly. We're going to try a limit comparison test against the series 1 over n. I'd like you to pause for a second, find your notes for limit comparison test, and take a look. So we're taking the limit as n goes to infinity of an over bn. An here is 1 over log of n, and bn is 1 over n. We're going to simplify this. So we get the limit as n goes to infinity of n over log of n. And we know that, so we can either use L'Hopital's rule, or we know that, that polynomials grow much faster than logarithms. This limit is always going to be equal to infinity. You should also feel totally comfortable using L'Hopital's rule here. That's totally fine. Okay, so now we need to interpret this result. Since the series 1 over n diverges, and the terms 1 over log of n are bigger than 1 over n, right? Since the ratio goes to infinity, 1 over log of n gets much bigger than 1 over n, then this series 1 over log of n diverges. Okay, that means, right, so we've obtained our results. So by the limit comparison test, this series diverges, and so we can conclude that our series converges conditionally. It converges, but the series whose terms are the absolute value of our series does not converge.